The next thing we need to do is apply what we've learned about right triangles and finding missing sides or missing angles. And we want to apply that to real-world application type problems. So let's say that you are sitting in the top of a tree and the angle of depression to your car is 40 degrees. The car is 100 feet away and you want to figure out how tall the tree is. So if we're looking at a tree, here's my awesome drawing. You should maybe add some awesome drawings to your papers as well. And then we have a car somewhere over here. There's my awesome car. And I am, of course, hanging out in the top of my tree. So here I am just hanging out. The angle of depression to your car, what does that actually mean? Well, we need to figure out maybe what angle of depression is. And here's kind of just a quick little picture here to give you the difference between angle of depression and angle of elevation. The biggest thing is that both are always from the horizontal. Okay, so a lot of times we're talking about your line of sight. So if you were to look directly out, your line of sight would be horizontal. If you have to look up, the angle of elevation would be from that horizontal. So if I had to look up 23 degrees to see this airplane, then that's from the horizontal. From here to here would be 23 degrees. And if my angle of angle of depression is 40 degrees, that's down from the horizontal. So in this particular picture, and if I draw kind of my line of sight to this car, a lot of times we see, okay, here's that right triangle, and we know that this is 100 here. A lot of times we just assume that you can fill this in because it's one of the angles of the triangle, and we just write 40 degrees there. But really, that's not where the 40 degrees belongs. This is your horizontal line of sight, so your angle of depression is down from that horizontal. So this is actually where the 40 degrees belongs. And then you can do one of two things. You can either say, okay, well, if this is 40 degrees, then I know that this angle inside the triangle is actually, whoops, not 60, what am I drawing? Let me undo that. 40 away from 90, it's going to be 50 degrees. So let's write 50 degrees. I can work with this triangle now, or if I wanted to, I could have just kind of dropped that perpendicular and I could have worked with this right triangle out here. Totally up to you, but remember our goal here is to figure out the height of the tree. So I'm just going to label this H. So if I'm going to use the black triangle here, and I know that from 50 degrees, I know the opposite over here is 100, so this is the opposite. And then this is the adjacent side. So actually maybe I want to call that A just so that you don't confuse that with the hypotenuse. So, or we can even call it, let's just call it X because we're pretty used to finding X. So opposite over adjacent, we know that this is going to be the tangent. So we're going to say the tangent of 50 degrees equals 100 over X, and we're going to solve for X. So that means X times the tangent of 50 equals 100, and therefore 100 divided by the tangent of 50 will actually give us the height of that tree. So again, in our calculator, let me clear that out. Make sure that your mode is in degrees, and then we're going to type that in. We need 100 divided by the tangent of 50. So 100 divided by the tangent of 50 degrees, and we get 83.9. And so our units are what? In feet. So 83.9 feet tall for that tree. Let's look at another example. A giant redwood tree casts a 532-foot shadow. So if this is my giant redwood tree, if it has a shadow, let's say if the shadow is over here, then that means that we know the sun is somewhere over here, right? The shadow is 532 feet, so let's plug that in. We want to find the height of the tree if the angle of elevation of the sun is 25.7 degrees. So remember, angle of elevation in this case is going to be from the horizontal, so from the earth there, that angle going up to the sun, right, over this way, this angle here is 25.7 degrees, and we want to find the height of the tree here. So again, we have opposite and adjacent, so we're going to say the tangent of 25.7 equals x over 532. Let's write the right numbers there. So multiply both sides by 532. So 532 times the tangent of 25.7 will give us the height of that tree. So 532 times the tangent of 25.7 and it looks like the height of our tree is 256 feet. So 256 feet for the height of that tree. Now, of course, these can get a little bit more intense if we look at, for example, this problem. An airplane is flying at an elevation of 5,150 feet directly above a straight highway. Two motorists are driving cars on the highway on opposite sides of the plane, and the angle of depression to one car is 35 degrees and to the other is 52 degrees. How far apart are the cars? So let's first draw, here's our airplane. Okay, so this is our plane. We know that it is directly above a highway and it is 5,150 feet up. On one side we have a car over here. We'll just call this car A. And then there's another car over here, car B. We want to figure out how far apart they are. Let's talk about the angle of depression. So from the plane, remember we have that horizontal coming out. So the angle of depression down to that first car, that means this angle right here is 35 degrees. And then on the other side, again, here's our horizontal. So the angle of depression down from that to car B is going to be 52 degrees. And we want to figure out these two sides. I'll call this side X and this side Y. And when we add them together, we will be able to say how far apart the cars are. So again, it's up to you kind of how you want to work this, but if you were to just kind of drop the perpendiculars here, you could say this is also X and this is Y. So you could use actually this top triangle if you wanted, or you could figure out the measure of this angle here and this angle here and use these innermost triangles. It's completely up to you. But we know that this side is 5,150. We know this side is 5,150. So really we just have two different triangles that we need to figure out a missing side of and then add those together. So let's talk about this triangle over here. We have the opposite side and we're trying to find the adjacent. So that means that we know that the tangent of 52 equals the opposite 5,150 over x. So that means x is going to equal 5,150 divided by the tangent of 52. And then over on the other side, this is our opposite and our adjacent. So in this case, the tangent of 35 equals 5,150 over y. So that means y is going to equal 5,150 divided by the tangent of 35. So we just need to figure out both of these. So 5,150 divided by the tangent of 52, 5,150 divided by the tangent of 52, this is going to give us x. So 4,023.62. So over here, 4,000, what did I say? I can't remember anything. 4,023.62. And then for y, 5150 divided by the tangent of 35. So 5150 divided by the tangent of 35. And for that, we get 7,354.96. That's going to be y. So let's just go ahead and add that x, 4,023.62. And that means our total distance is about 11,378.6. So our final answer here, 11,378.6, and this would be in feet. So just make sure, draw a picture. That always helps me out, and just follow along with what you find in your in the problem. You know, angle of elevation, angle of depression. Make sure you use that from the horizontal. Set it up, and then use your trig. Sometimes you're finding sides, sometimes you're finding angles, but the picture really helps.